Hello, and welcome to 5-Minute Math. Today we are looking at the 4th grade concept of classifying 2D shapes. This is standard 4.6D in the great state of Texas, and we are using item number 30 of the 2019 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So we have these 3 polygons. They belong in the same group, and we just need to find a statement that best describes the polygon. So first, let's make sure we define that term because they use it twice. So polygons are closed shapes that have straight sides. So no open shapes like horseshoes and no circles. And so we've got a rectangle. We can at least name them. We know what these are. That's a rectangle. We've got a triangle. And then we've got a square. But we need to be able to describe them with some of these terms. So we've got parallel, obtuse, right, acute. So let's start with F, and let's take a look at least each polygon has at least one pair of parallel sides. All right, so parallel sides or parallel lines are lines that, first off, they don't intersect, so they never touch. But not only do they not intersect, they stay the same distance apart. And so when I'm thinking of parallel, I'm really thinking of, like, look at those two L's in parallel. Those two L's in parallel are straight lines that don't intersect, and they stay the same distance apart. Sometimes you can kind of see it like this. Think of like the two lines on either side of a road. So those are parallel. So let's see. This top side is parallel to the bottom side. So I'm going to note that with a single hash mark. And then quite honestly, this other side to the left is parallel to this other side on the right. So the rectangle has two pairs of parallel sides, the top and the bottom, and the left and right. Unfortunately, this triangle doesn't have any parallel lines. Each line intersects, and there's not one that is one that would be like the exact opposite, staying the same distance apart. So there's nothing in the triangle. Like if I wanted to draw one on the triangle, I'd have to kind of do like something like this. That could be parallel to that. Or I'd have to kind of do something like this that'd be parallel to that, or something like this would be parallel to the top. But you see how none of those fit inside our triangle. Square, just like the rectangle, the top and the bottom are parallel, the two sides are parallel. So this is good for 2 out of the 3, but it doesn't work for the triangle. So that's the one that kind of doesn't work for us. Let's check G. Each polygon has at least one obtuse angle. So the rest of these are angles. So let's figure out what our angles are first. And I'm going to start with a right angle because everything revolves around this right angle. So a right angle, it looks like this, and it equals 90 degrees. And usually you'll get like a little square in there to show that it is perpendicular. One line is straight up, one line is straight across. I like to think of it as a square corner because just imagine the corner of a square, and that's what you're going to get. So that's a right angle, is a 90-degree angle. So obtuse, which is what we're looking at in G, is greater than 90 degrees. That's all it is. Any angle greater than 90 degrees. So some examples kind of might be like this. It could also be like really, really big, or it could be just like barely above 90. Any of those work as long as it's greater than 90. So our acute, that is less than 90. So we're looking at smaller than 90 like this. So each polygon has at least one obtuse. None of them actually have an obtuse angle. Each one has a right angle. Well, the rectangle and squares are filled with right angles, all 4. And take a look at this triangle right here. It actually has a right angle, but the rectangle square do not have an acute angle, so our answer is H.